Whatever you're doing, I need you to put it down and listen to this story. We are possibly looking at the miracle in cancer detection. Is it really the one that the world has been waiting for since the beginning of time? Biotech Tezar Labs says it has created the very first pan-cancer test and claims a single blood test predicts tumors a year before they form. I know you guys have questions. I certainly do. We have the guy who is behind this company, which made the discoveries, here in a Fox Business exclusive. Tezar Labs founder and CEO Ash Tripathi.
There are 200 different types of cancer, 3,000 subtypes of cancer. We detect all of them from a blood sample. Not just that, we detect it earlier than known technologies because we can detect it when it is PET negative. That's stage 0, not stage 1. Latest research in the US shows that as soon as you do a biopsy, you speed up the activity of the tumor. I can give you the readings of all of them straight from a blood sample. We can tell you you do not have cancer and you will not get cancer for the next 1 year. We realize that if you look at a causative marker, you see it very clearly even before the tumor has formed. If we do this test once a year, we will turn cancer into an early stage disease. If you detect it at stage 1, the average cost was about $40,000. If you detected it at stage 4, it was $400,000. There's a very real cost to detecting cancer late. Hi, my name is Ashish Tripathi. I'm the CEO of Tezar Labs. Thank you, Dr. Christian, SIP Balians. I'm honored to be speaking to such a distinguished audience. I would have loved to be there in person. I'm getting an award, the Edison Award in Miami in a few hours, which is why I've had to make this particular presentation through a video link. But my senior executives are there. They'll perhaps be able to explain the science in a lot more detail and perhaps also show you examples of these reports that I will talk about. The screening breakthrough has been well covered in the media. We have got a US patent granted. We have already published the science in Oxford Academy Stem Cell Journal. It was retweeted by Harvard professors, NHS professors, University of Paris professors. I have spoken at the House of Lords in London. I have spoken at the World Government Summit, and I have been extensively covered in the media. Essentially, the breakthrough is simple. While most liquid biopsy companies were busy looking at resultant markers of the tumor, pieces of the tumor that find their way back into the blood, CTC, ctDNA. The challenge with this is that at the early stages, you do not see many of them. In fact, NHS has put out a paper saying that no liquid biopsy gets more than 20% sensitivity at stage 1 and more than 30% sensitivity at stage 1 and stage 2 combined. As compared to this, we are looking at a causative marker that shows up in the blood a good 12 to 18 months before the tumor even forms. There's an epigenetic change happening on a stem cell that creates a cancer stem cell, that creates cancer cells, that creates a tumor. And hence, our sensitivity is actually in the 90%. Now, while we have already published our Indian study, we have just completed an NHS study by way of Western ratification, and that we hope to be publishing soon. Having said that, I promised Dr. Christian that instead of talking about screening, which has been largely covered, I am instead going to speak about the B-Cubed test, which has significant applications, and the test has just been launched in London for 4 diseases: onco, diabetes, cardiovascular, and neuronal diseases. Now, essentially, the implication of the breakthrough was that we are looking at a particular set of cells that make up only 0.025% of the total number of cells. The reason we have a US patent is because if you do not enrich the cells, your data is impacted by 99.9% of the cells, which are largely blood cells, and therefore distorted. You must be able to enrich these cells. But essentially what we realized was that the transcriptomic markers that we are getting from these cells are akin to the information that you would get from a tissue biopsy. But it's like data that we have not seen, because while you are used to seeing the biopsy data of one organ, there's really no individual out there who's going to be willing to do multiple biopsies to give you multiple organ data set. When we enrich this data from the blood, I am picking out neuronal markers, lung markers, renal markers, kidney markers, heart markers, bone markers, everything. The way we use the data is HRC tells you whether cancer is absent or present, or if you're at high risk. But when we have done the sequencing information of these cells, we are literally able to tell you what is the primary, what are the somatic mutations, what are the pathways. These are the 13 known pathways implicated in cancer. Oncologists are aware of it, JAK-STAT pathway, WNT pathway, and so on and so forth. Now, like I said, oncologists were aware of this because this dictates what kind of medication could potentially work on these patients. But they thought they could only get it through an invasive biopsy. We get this data from the blood sample. These are all those 533 genes in a diagrammatic format from the KEGS database. Let me interpret this data. The white genes mean that they are normally expressed. Green means they are dysregulated but not in the harmful direction for cancer. Red means that they are dysregulated and harmful in cancer. Tumor suppressor gene, if it's downregulated, that's harmful in cancer. A cell cycle gene, if it's upregulated, it's harmful in cancer. Now, when we get this pathways analysis done for you and me, this is the kind of picture that we see. Perhaps we may get a few more reds, a lot more greens. We are aging. But this is what we see for a cancer patient. We're not colorblind. We can see the difference. This is what we see for a patient who's on treatment. This is what we see for a cancer survivor. In the oncologist's hand, this particular data is genuinely important because while they can do a biopsy once and therefore start giving treatment, they cannot do a biopsy again and see the impact of their treatment, and therefore they wait for the next PET scan to see if the tumor is not growing. They assume that their medication is working. But you cannot do a biopsy again and again. We can tell you the mTOR pathway was active, your medication treatment protocol has worked, but now the WNT pathway is on the rise. You need to change your treatment protocol. That's the level of information that we can actually provide. In the oncologist's hand, this is a response analysis tool. This is a remission analysis confirmation tool. This is also a relapse tool for cancer survivors. Having said this, oncologists understood the importance of molecular markers in cancer because a lot of us are willing to do an invasive biopsy in cancer because we are fighting the battle of our life. Having said that, how many of you would do an invasive biopsy of the pancreas for diabetes, or worse, an invasive biopsy of the brain tissue for neuronal degenerative diseases? This is what the insulin secretion pathway looks like for a non-diabetic. This is a pre-diabetic. This is a diabetic. This is the neuronal pathways of a non-Alzheimer's patient. This is pre-Alzheimer's. This is Alzheimer's. We are seeing subtle differences between Huntington's, Parkinson's, Alzheimer's, and dementia markers on neuronal pathways, but detected from stem cells in the blood. It's a very interesting example. A patient did his onco test. Of course, our data scientists were focusing on his onco markers, but our AI/ML system picked up that he was wearing a pacemaker, and we noticed that his LMNA gene, which is responsible for the rhythmic functioning of the heart, was downregulated, but there are genes that are responsible for oxygenation levels of different organs which were upregulated. That's the kind of information that we are getting simply from a blood test. The reason this has implications in longevity is because in a few years, we expect to have panels for 30 to 50 organs. We will have markers for your muscular system, your endocrine system, your metabolic system, and so on and so forth. Now imagine if you can do 2 time point studies, if you're doing a treatment protocol, rather than comparing your data with your age-matched cohort, if we are able to compare your data with you at a molecular level, at an organ level for multiple organs from a blood test. This is why this particular breakthrough has big implications for the pharma industry, the diagnostics industry, the insurance industry. These are my contact details. Please feel free to reach out to me or speak to our senior executives who are at the conference. There is a special offer for anyone participating in this conference who wants to get this test done. Also, there's a fishbowl contest where 5 of you can get a test done for free. Dr. Christian, SIP Balians, thank you so much. I'm honored.